This video is going to take a look at some of those inverse trigonometric function questions that are just a little bit more awkward than we're used to seeing. So in the log tables, there is instructions on how to manage and deal with inverse trig functions. And if we look at sine inverse, it says that if you have the function sine inverse of x all over a, it gets differentiated to 1 all over the square root of a squared minus x squared. Now, in our question, the x is not in the same position. That x is on the top of the fraction and our x is on the bottom of the fraction. So if we're actually going to be able to use that formula, I need to make sure that my x is in the right position and that structurally it has the same setup as the formula. So I need to pull out my indice rules and I need to reverse that x or all over x into being 4x to the power of something, and I can do that using the rule 4x to the minus 1, so using to the power of minus 1 to take it out of being a denominator and using index notation instead. So again, I can write that as sine inverse of 4x to the power of minus 1. So what I've done there is make sure that my x is in the right position so that structurally my question is the same as the formula in the log tables. Now in the log tables, that is sine inverse of x all over a. I need to have a fraction. How could I write this as a fraction? I could just put it all over 1. From here then, I just need to identify my a, and it's a matter of filling into the formula. So dy dx is going to become 1 all over, and our x is all of that. It's not just the it's not just the x to the minus 1, it's the 4x to the minus 1. So when I'm subbing that in, I'll take note that I have to add in all of it. So I'm going to have a squared, and our a is actually 1. So I'm going to put in 1 squared, following the formula there. So 1 squared minus, and then our x, remember, is all of the 4x minus 1. So that's where I'm going to fill it in inside here now. So all of that squared. So 4x to the minus 1. So what I've done is I've used from page 25 of the log tables the formula out of the box. Now remember, anytime you take formula out of that box, it must go with the chain rule. And if you're unsure why, look at the U substitution. Try it out the long way and you'll start to realize why all of those rules must go with the chain rule. So what does that mean? The chain rule tells us you differentiate it and then you multiply by the differential of what's in your bracket, or what's your x here, what's the second part of the function for our composite functions. And that is going to be the 4x to the minus 1. And if I'm going to be able to differentiate 4x to the minus 1, what will that give me? It'll give me minus 4x to the minus 2. So be careful there. Don't forget that the chain rule has to be put with any of those differentials out of the log tables on page 25. Multiplying that out then, I get 4x to the minus 2 all over the square root of 1 minus, that's going to be 16x to the minus 2. So using indice laws there to square out the 4, square out the x to the minus 1. And that's your final answer. So here is another unusual question on inverse trig functions. Once again, the x that we are focusing on is in the wrong position. So structurally it's different from what's in the log tables. So again, my x squared here is on the bottom. I want it to be on the top. So step 1 is I'm going to use my laws of indices to rearrange that. I'm going to have cos inverse 2x to the minus 2, and because it deals with a fraction, I'm going to put it all over 1. Now I have to identify my x and my a. So my x is all of this part and my a is what's on the bottom, which is 1. And I'm just going to fill in to the formula as I see it in the log tables. So it tells me that dy dx is going to go to minus 1 all over, and then it's going to be the square root of a squared, which is 1, minus x squared, which is 2x minus 2, all squared. And then remember, if I'm ever using one of those rules from the log tables, it goes with the chain rule. What does that mean? It means I have to multiply by the differential of what's up here. So what's in the bracket, what's the second part of the composite function. And I'm going to have the differential of 2x to the minus 2. So the rule is multiply down by the power. So I get minus 4x, take 1 off the power, to the minus 3. And I'm then going to multiply that out so that I get 4x to the minus 3 all over. And then we're going to have our 1 minus 2x to the minus 2 squared. So it's 1 minus 4x to the minus 4. Now, you can leave it like that and start your subbing in or whatever the rest of the question was, or you can rearrange it. I could write that as 4, and then it's going to be all over x cubed, all over the square root of 1 minus 4x to the minus 4, which again could be written as a fraction. So we're going to have 4, and then I could write that as x cubed root, so square root of 1 minus 4 all over x to the 4. So a little bit of tidying up at the end, but that's just using our indice rules. There's no more new stuff there, no more differentiation or calculus involved. It was just a little bit of algebra.